Hey friends, my name is C and you're watching MakesItEasy, and welcome back to a new video for A-level mathematics. And today we have 2.4 Loci in the Argand diagram for the questions video. And we'll get started with the first question, but before we get into it, don't forget to leave a like, subscribe, and ring the notification bell to listen to any future videos. And we'll get started with the first question. And these questions are from exercise 2E from the core Peer 1 textbook from Edexcel, so you can check it out yourself. But anyways, here's question 1. Sketch the locus of z and give the Cartesian equation of the locus of z when a, h, and I, like the different questions. So I'll split into to 3 different parts. So a, h, and I. Sorry, I should do this, h and I. So a right here, modulus of z equals to 6, right? So we know that z can be rewritten as x plus iy. So this can be x plus iy. Modulus of x plus iy equals 6, and we can basically just reverse the modulus by doing a square root symbol. X squared plus y squared, where we basically just square root we square each term, like this and this, the real and imaginary part, and then the root of it equals 6. And to reverse it, we basically just square both sides to get x squared plus y squared equals 36, plus y squared equals 36. So this is a Cartesian equation. And we can see that it's basically a circle, so the locus is a circle, and we can plot on the Argand diagram, the real axis, and the imaginary axis. So IM is Z. So we can just plot this circle right here. So around, let's say 6, 6, minus 6, and minus 6. And the center is in the origin, therefore we can just plot a circle like so. And we can just label this as 6 and minus 6 and minus 6 and 6, and that's the answer. And for the second part, z plus 3 plus 4i, the modulus of all of them, equals 4. So we can substitute z by x plus iy. So x plus iy plus 3 plus 4i equals 4. We can collect like terms, which is basically the real and imaginary part. So it'll be x plus 3 plus y plus 4i modulus equals 4. We can square root and square the inside individual terms, x plus 3 squared plus y plus 4 squared, and this basically get rid of the I equals 4, and therefore the Cartesian equation will be x plus 3 squared plus y plus 4 squared equals 16, right? So we can now basically just plot it on an Argand diagram as well, and we can see that it's in the form of a circle, so that the locus will be in this as a circle as well. So like this. So we know that from this information, we know the center of the circle is at minus 3, minus 4, because it's always the opposite sign, and the radius is 4, because it's basically the square root of this number. So let's look at minus 3, minus 4. So minus 3 will be around here, and minus 4 around here. So we know that the circle has a radius of 4, right? And we know that this is minus 4. That means it will just touch this point right here, and then it will go beyond the real axis right here, because this distance is 3, and the radius is 4. That means it will go up by 1 unit. So this is 3, and this is 1 unit. So let's say this is around 1, and so the circle will be centered at 3, 4, and we can just draw a nice circle here. Oops, it's not a circle. Let's draw it nicely, like so, and just move it over to the right a bit, like so. It's not really accurate, but that's basically it. And for the last part, the modulus of z minus 5 plus 6i equals 5. So we can just rewrite z as x plus iy minus 5 plus 6i equals 5. We can collect like terms as well. So it'll be the modulus of x minus 5 plus y plus 6i modulus equals 5. And we can square root everything and square individual terms. And I'm just going to skip some steps. So it'll be x minus 5. So new color. It'll be x minus 5 squared minus 5 squared plus y plus 6 squared equals 25. So from here we can see the center of a circle it's at 5 minus 6, right? So center is at 5 minus 6 and radius is 5, right? So we can plot an Argand diagram as well. So the real axis and the imaginary axis. Imaginary axis and the real axis. So 5 around here and 6 around here. So this will be the center of a circle, and it will be helpful to label the center of a circle. So we know that this distance here, 5, this distance here is 5 units, right? That means it will just touch the imaginary axis. But we know that this distance here is 6, right? So it will touch this line right here, where it's equal to -1. Therefore, the circle will be around like this. Sorry, it's a bit out of the screen, but it will look something like this, where it just will touch the imaginary axis, and it'll be like this. So it's a bit out of the screen here, but you basically draw a circle, the whole circle. Moving on to the next question, we have number 4, or the second question. On an Argand diagram, the point P represents the complex number z. Given that z, the modulus of z minus 4 minus 3i equals 8, find the Cartesian equation of the locus of P. So we know that we can just basically turn it into the Cartesian equation by substituting z by x plus iy. So let's just do that. So it'll be x plus iy minus, let me just zoom in, x plus iy minus 4 minus 3i equals 8. Collect like terms, you get x minus 4 plus y minus 3i equals 8. You can basically just square root everything and square individual terms in the modulus symbol, and therefore this gets us x minus 4 squared plus y minus 3 squared equals 64, or 8 squared, like so. And sketch the locus of P. So we basically have this locus right here. It's basically this locus, which is basically a circle with center at 4, 3, center at 4, 3, and radius at 8, right? So we can just sketch right here, an imaginary, so the real axis and the imaginary axis, like so. Center at 4, let's say this is 4 and this is 3, so this will be the center, right? So this is 4, oops, this is 4 and this is 3, and the radius is 8, so it will be quite a large circle. And if it's going to freehand draw it, it will look something like this, right? And just ignore the parts where it overlaps the numbers. So part C, find the maximum and minimum values of the modulus of z for the point of this locus. So remember that the minimum value for the modulus, or basically this symbol right here, the modulus of z, is basically the distance from the origin to the center minus the radius. And for the maximum value of the modulus of z, it will be the distance from the center, so from the origin to the center of a circle plus the radius. So we can see this distance right here is basically the origin to the center, and we can notice that it's a Pythagorean triple, right? Because we know that this distance here is 4 and this is 3, that means this must be 5. Or we can also use the Pythagorean theorem where we do a squared plus b squared equals c squared. But anyways, this is a distance of 5. That means, let me just write here, the minimum value for the modulus of z will be equal to the distance from the center to the origin, which is 5, minus the radius, which is equal to 8 from here. 8, right? So 5 minus 8 equals minus 3. But we just have to take the modulus of it, which is basically the positive value, which is equal to 3. Like so. Let me just use a new color. So this will be equal to 3, like so. And the maximum value for the modulus is that max equals 5, basically the center to the origin, plus the radius, plus 8. And therefore this gives us 13, like so. And that's the answer. And next question, Given that the complex number z satisfies the equation the modulus of z plus 6i equals 4, find the exact maximum and minimum value of the modulus of z. So it will be helpful to first draw out the diagram. So we know that this is basically, this can be simplified into x plus iy plus 6 plus 6i, and therefore this gives us x plus 6 and y plus 6i, the modulus of it. Therefore this has center at minus 6 and minus 6, right? And the radius is of course 4 because it's written right here. So using these basic information, we can construct a simple and nice Argand diagram. So here we have an Argand diagram. So it's centered at minus 6, minus 6. So I should probably just redraw this. Minus 6 around here. And the radius of 4, which gives it around here, where I just ship it here, like so. Find the exact maximum and minimum value of z. So as we saw just now, actually let me just write this out. As we saw just now, the maximum value is where it's the origin to the center plus the radius, and the minimum is the center to the origin minus the radius. So we can just find this distance right here. So we know that this is 6 and this is 6, right? Therefore we can find this hypotenuse, which basically uses the Pythagorean theorem. So part A, it will be C. So it will be a squared plus b squared equals c squared. C will be equal to the root of a squared plus b squared. In this case, a is equal to 6 and b is equal to 6. Therefore, it will be 6 root 2. C is 6 root 2. And we know that the radius is 4. Therefore, we can just do it quite easily. So z of the maximum modulus is basically c, which is 6 root 2, plus the radius, which is plus 4. Therefore, maximum is 6 root 2 plus 4. And that's it. And for the minimum, it will be 6 root 2 minus 4. So let me just rewrite it. So it will be 6 root 2 minus 4, like so. And next question. Find the range of values for theta where minus pi is less than theta is less than pi, for which the argument of z minus 4 plus 2y equals theta, and this circle has no common solution. So we know that this is basically equal to arc z minus 4 minus 2i. Therefore, the argument has a center of 4 minus 2. So it will be around here, 4 and minus 2, which is around here, 4 minus 2. Therefore, you can basically just find some values for the theta. So we know that theta equals 180 degree, and basically if you go negative, it will be minus 180 degree, and if you go positive, it will be 180 degree, right? And we can actually notice that this actually forms a nice straight line, because the tip of this circle right here is actually minus 2. Therefore, we know that if the angle of the argument were to be pi or 180 degree, the circle and the line would touch, right? That means that there will be a solution, and we can't do that. That means the angle for the upper value for the angle, it must be pi, but it has to be less than pi. So we can just deduce it by writing it. So theta has to be within pi, right? So now we just have to find the angle, this angle right here. We basically just draw this where we make a tangent. And then by doing this, we have to find this angle here. Let me just write this out. We have to find this angle here. And there are many ways to do it, but I think the way that we can do it quite straight away is to find this angle first. And we can do 180 minus that angle. And we can find that angle by doing some trigonometry. So we know that this is a straight line over here where it's a horizontal straight line. We know that this meets at the 90 degree. And this meets at 90 degree. Therefore, these two angles are equal. This and this, they're both equal, right? And we know that the radius of a circle is 4. Because we can see from here, that is equal to 4. And then this is 4. And this whole distance here is 10. Because we can use some, because we know that this distance here is 6 and this distance here is 4. Therefore, we can use trick to find this angle right here by, let me just zoom out, because we know that it's equal to this triangle for tan and alpha, and therefore alpha will be arctan or tan inverse 4/10, which gets us, I'm just using my calculator and put it in radians mode. Tan inverse 4/10, it'll be equal to 0.381. And we need to double it so that we can find this whole angle right here, right? Therefore, double it gets us 0.761. And therefore, we have this angle already. We have to find this angle here, which is basically 180 or pi minus 0.761, which gets us, I'm just writing it here, pi minus 0.761, which is 2.38, and that's the answer. And you have to remember to put the minus 2.38 because it's going in the negative direction. And we have question 16. Sketch on the same Argand diagram the locus of points satisfying A and B, where they are both different, one's modulus and one's argument. So we can just plot it out and draw a big diagram right here. And this, the real and imaginary axis. So we know that this has center of 3 minus 2 with radius of 4, and this has center of 1, 0, and an angle of minus pi over 4, right? So let's just draw the circle first. So it has center at 3 minus 2, so 3 around this and minus 2, so 3 minus 2 around here, and therefore we can just draw a nice circle like so, at 3 minus 2 center, like so, right? Let me just rub this point out. Oops, let me just rub this. Yep, and this. So this, here. So this is a circle, and we have to draw the argument. So this is around 1 here, so 1, 0. And the angle pi over 4 is basically equal to the angle of 45. That means it's basically of the line y equals minus x, but with like a shift to the right, right? So we can actually see that the argument actually passes the point 3 minus 2. So this is the argument of the line. So as you can see, they actually pass through one another, like so. And part C, the complex numbers z satisfies both of those dimensions, the modulus and the argument. Given that z equals a plus ib, find the exact value of a and the exact value of b. So there are multiple ways to do this, but the way that I would do it is that I would turn these two into Cartesian equations and solve them simultaneously. So let's just do that together. So the first equation will be equal to x minus 3 plus y plus 2i equals 4. Because what I did was that I just substitute z by x plus iy and collect like terms. And therefore the Cartesian equation will be x minus 3 squared plus y plus 2 squared equals 16, like so, the first one. And the second one, it will be x plus iy as well. So it will be the argument of x plus x minus 1 plus iy equals minus pi over 4. And therefore this gets us y over x minus 1 equals 10 minus pi over 4. And if you don't know how to solve these kind of equations, you can check out my previous videos on modulus and argument forms and modulus and arguments. So this will be minus 1, and therefore the equation is basically y equals minus x plus 1, right? So we have two equations here. We have, let me just write it here. We have this circle equation and we have this line equation. So we have to solve them simultaneously by doing substitution. And keep in mind that you will actually get two solutions. You will actually get one solution here and one solution here. And the reason why we disregard this solution here is because while drawing arguments, we only consider this line right here, which is basically called the half line. So we can solve them simultaneously. It will be x minus 3 squared plus minus x plus 1 plus 2 squared equals 16. and and if we were to solve this, you will actually get two values as I mentioned, and one x value will be smaller than the other, and one x value will be bigger. You will reject the smaller x value because it will go into this region right here, and you have to accept the big x value, which I'm going to cheat and just use my calculator to find, and the x value will be equal to 3 plus 2 root 2. And if you were to use a calculator to find the corresponding y value, that means y will be equal to, let me use new color. So as I mentioned, x will be equal to 3 plus 2 root 2, and y will be equal to minus 2 root 2. And that's the answer. And lastly, we have this question. Given that argument of z plus 4 equals pi over 3, sketch the locus of z on an Argand diagram. So we know that this has center at minus 4, 0, because it's basically arc of z minus 4. And it's helpful to write in terms of z minus something because this would directly be the center. And we know that pi over 3 is equal to 180 degrees over 3, which is equal to 60 degrees, right? Therefore, we can just plot this locus right here. Oops. We can just draw the real axis and the imaginary axis. And the half line will be at the center minus 4, 0. And this will be here. And go here, and you can find the y-intercept, but it's not relevant in this case, or you can just plot it there so that you know what angle, what point it is. And this point right here, this angle, will be pi over 3. And part B, find the minimum value of the modulus of z for the points on this locus. So this is quite different from the other circle question because in this case there's no radius. So what you do is that you basically just need to know the definition for the modulus of z, the minimum value. So the minimum value of the modulus of z is basically the closest distance from the locus to the origin. So as we know, the closest distance will always be the perpendicular gradient from the locus, right? So from this center right here, we have to draw a perpendicular line, which has the perpendicular gradient to the locus. So this is from a 90 degree, right? That means what we have to do is you have to find the gradient of this argument line, or sorry, the locus, and then you have to do the negative reciprocal to find the gradient of this line because they are both negative reciprocal, which means that they are perpendicular. So first we have to find the Cartesian equation of the line. So it will be argument of x plus 4 plus iy equals pi over 3, and this will be y over x plus 4 equals tan pi over 3. So tan pi over 3 will be equal to root 3, and this will be equal to y equals root 3x plus 4 root 3. And we're only concerned with the gradient at this part, and the negative reciprocal of this will be equal to minus 1 over root 3x, right? That means y equals minus 1 over root 3x will be the equation of this line right here, this line. And keep in mind it's plus 0 because it crosses the origin. Therefore, we have two equations right here. One is this, and one is this. And you can basically just solve simultaneous equation. So we can just solve it right here. I'll bring it over here, actually. So it'll be root 3x plus 4 root 3 equals minus 1 over root 3x. So we can solve to get x equals, I'm just use my calculator. It'll be root 3 plus 1 over root 3 for the x. Then you do minus 4 root 3 divided by that number. And that gets us x equals minus 3. And you can find the y value by doing minus 1 over root 3 times by root 3. And this gets us root 3. That means you know that this intersection point right here is equal to minus 3 and root 3, right? So we're not done yet. We have to find the minimum value of the modulus of z. That means we have to find this distance. And since we already have this point of what this point is, we can just use the distance formula to find the distance of this, which is basically the distance formula is root x squared plus y squared, which is equal to root of minus 3 squared plus root 3 squared, which is equal to, let me just put into my calculator, minus 3 squared plus root 3 squared, which is equal to 2 root 3. Let me just write it down. Equal to 2 root 3. And this is the final answer. And that's it for this questions video for 2.4 for loci in the Argand diagram. And I hope you all find it useful and helpful. And if you did, please leave a like and subscribe and ring the notification bell so you don't miss out on any future videos. And if you have any questions or any comments regarding my channel or my YouTube or my Instagram, you can leave them down below and I'll reply to them. And check out my social media in the description, for example LinkedIn or YouTube or Instagram. And if you need any learning resources or any teaching resources, you can check out my website in the description, or you can type it out in your browser at www.MakesItEasy.com. And I hope you all find it useful and helpful, and I'll see you all in the next video, which will be 2.5, which is the penultimate lesson for for topic 2, which will be fun and interesting because it involves shading as well. But anyways, that's it for this video, and I'll see you all in the next video. Until then, stay safe and happy learning.